Now sometimes I'm going to give you a function that isn't in a nice geometric form, or you can't even get it there. Now let me look at f of x as log of x. What do I know about log of x? I know f prime of x is 1 over x. Can't integrate this, but I can take the derivative of it. Now you remember I can find 1 over x centered at 1. As a matter of fact, I already have. So I'm just going to pull that result. 0 to infinity. This is negative 1 to the n, x minus 1 raised to the n. All right? So I know this is what 1 over x can be expanded as. So now let me integrate this. All right, so I'm going to integrate dx over x. And when I do this, I'm going to get natural log of x plus a constant. I'm going to put a little prime here. Now when I integrate this side, let me integrate this side over here. So this is equal to, when I integrate this, it's a sum as n goes from 0 to infinity. Minus 1 to the n stays the same. X minus 1 to the n plus 1 divided by n plus 1. All right. So now I have this c in there. Let me put in, at what point do I know log of x is 0 when x is 1? So I can pick a point. So at x equal 1, I have the log of x, or I have the log of 1, excuse me, plus c prime is equal to, and this side over here is 0. And that tells me my constant is 0. So what I now know is that I can write the log of x is equal to the sum as n goes from 0 to infinity of negative 1 to the n, x minus 1 to the n plus 1 divided by n plus 1. Now, I've already shown that up here I have a radius of convergence of 1, and my interval of convergence is, now I did this with the other problem, between 0 and 2. So I do need to check the endpoints. At x equals 0, what do I have? I have the natural log is what? I can guarantee this isn't going to converge because I can't even write natural log of 0 down. It just is hurting my soul. So I'm just going to look at the sum. Minus 1 to the n times minus 1 to the n plus 1 divided by n plus 1. So this is going to wind up diverging because I have that 2n, so it's divergent. At x equal 2, this becomes a sum at n equals 0 to infinity, minus 1 to the n times 2 minus 1 to the n plus 1 divided by n plus 1. Now this is the alternating harmonic. So this converges. This is harmonic. I'm running out of room here. So it diverges. This is alternating harmonic. So it converges. So my interval of convergence is 0 to 2. And the radius of convergence is 1.